KEET TV presents Homework Hotline, the after-school show that fuses learning with fun. Watch local teachers bring the classroom on air and online. This is Homework Hotline.
Welcome to Homework Hotline. My name's Pam Halstead and I taught science at Fortuna High School.
My name is Amy Taylor and I teach 7th and 8th grade at Sunny Brae Middle School in Arcata.
Welcome to the show, everyone. We're so excited. It's 2022. This is the first show of the 2022 season.
Yeah, our 17th season. I know because this is my 19th year of teaching and I started here my 3rd year of teaching, so I just have to do that. And it's a 17th year and we're starting off the spring 17th season in 2022.
Yes,
so yay, welcome.
Thank you for joining us. We have a great show coming up.
Yes.
Amy's in charge.
So my integrated one and all of my 8th graders, it just happens to be right now, is graphing. And I feel like real world scenarios help us a little more, but just learning what slope and Y-intercept is and those kinds of things. What I might want to do is just do a background on that real quick, just on a blank whiteboard, just to tell you what that is. Okay. And I'm going to do that right now, real quick. So, what we work with a lot is an equation called y equals mx plus b. And do you happen to know what that equation is? If you do not, it is totally fine. Because
it's the slope.
Yes.
It's equal to the slope.
So m is the slope. And do you remember what b is?
No.
If you don't, it's fine. It's called the Y-intercept.
Of course.
So this is a nice form that we use a lot in 8th grade and integrated 1, which is like a freshman-sophomore class. And it's because this is called slope Y-intercept form. And then we can take, I like to write it out, especially when we haven't seen these words. I write it shorter if it's over and over again. But basically what we have is we have slope Y-intercept form. We can start with the Y-intercept, which is on the Y-axis. If this was the Y-axis, we could start somewhere, and that would be our Y-intercept, and then we could find some sort of slope out from that, and that would determine a line. And I have rulers and stuff like that. But that's kind of why we do that slope Y-intercept form. Also in real life, when we have 0 things happening in the X, what does 0 times m do? Turns it into a
0.
A 0. And then our b is really what our y is, because that's almost like our initial value. It's basically what you start with in real life. And the slope is basically the same as the rate. And so now we have this real life rate slope, but we have this real life y-intercept initial value. But sometimes we just, in those grades, just graph, but I figure we can kind of do it all together today. So we're going to just
ask?
Go ahead.
Okay,
yes,
so
absolutely.
Rate has to do with something happening over time. Is that?
Yes.
Okay.
Yeah, so rate is like miles per hour. There's so much background on this, but y is always dependent on x. And so miles, how far you go, is always dependent on time passing, say like miles per hour. So we go dependent onto independent miles per hour, and that's the same as slope, which is rise over run, and I'll talk about that a little more. I tell students, if you imagine these are my feet, I'm stepping up onto a stair. If you could just try to walk onto a stair and you just try to go X first, you'll just slam into it. But if you lift your foot and you step up, that's how we step upstairs. And that's the same as the rate, miles per hour, and just slope is rise over run or vertical change over horizontal change. That's the background. And then we will work through, and I'll just put up that generic graph because that's fun to see anyways. All right, and then we'll start on some problems.
Sweet.
Just give some background. Do you want to read this first problem?
Oh, sure, I would love to, because this guy is amazing. All you Warriors fans. Stephen Curry makes an average of about 4 3-pointers every game.
So we need to figure out, we're going to write that y equals mx plus b, because that's going to be kind of our main way we're going to graph. But we need to find out, what is my b?
Yes.
And what is my rate or my slope here? Now, does he have any, what are we starting at? Are we starting out like, does it tell us anything about where we're starting at?
Oh, you mean in the problem itself?
Yeah, and how many 3-pointers he makes to start with.
He makes 4 3-pointers every game.
Every game. Is that a rate or is that like a starting value? I can do
4 3-pointers every game. We could do the number of games and then the 4, and you could determine the rate if you had that.
Yeah, so the rate, so what we have here basically is a rate. So you have 4 3-pointers every game. Every 1 game. And so that's going to actually be our slope. It's going to be up 4 to the right 1 because that's our rate. Our initial value, we're just going to say we're at game 0 and there's 0 3-pointers because we don't know, we don't have any background. It's not like we're starting with his stat at game 12. We're just starting game 0, 0 3-pointers. He makes 4 3-pointers every game. So a lot of times, I'm just going to turn it this way.
Sure.
So we do different things like we will label, so like what is independent? Is the game happening independently or are the 3-pointers happening independently?
Oh gosh, okay, so the 3-pointers depend on the game.
Yeah, exactly. Okay. So independent X will have like number, oops, wrong kind of pen on here.
Oh dear, dang.
Oh, it's totally fine.
Okay.
I know, I'm like, well that one didn't show up, so
yes.
yeah, we're just trying. So number of games. And then here we have our number of 3-pointers because they're dependent. And then our equation over here is just y equals 4x plus 0, but do we need to write plus 0? We don't because it's the additive identity. So my equation is actually y equals 4x.
Cool.
So we're starting at 0, which is our y-intercept, and then we're going 4 3-pointers every 1 game, rise over run. 4 3-pointers every 1 game. 4 3-pointers every 1 game. And then you can go ahead and we have a ruler. Did you want to connect it for something to do?
Yes, yes, please.
Okay.
Connect the dots.
Yeah, so we call these lattice points like a lattice fence because they're right on the corners and they're accurate. If you do like a half and you don't get on the lattice points, you're going to put an arrow at the end because he will just keep making more games and more games.
We can hope.
Yeah, and that is the equation is y equals 4x, and that's really how you graph. Now, generic lines, the line would go forever both ways, but when we're doing real life, we say, well, we don't have negative games or negative 3-pointers, but if you were to graph for a class generically y equals 4x, it would just keep going, same slope, all like quadrant 1, quadrant 2, quadrant 3, quadrant 4. It will always go through 1 and 3, and I do say how we read left to right, we also look at graphs left to right. So as it goes up left to right, that's a positive slope, which is y equals 4x. So that's our first one.
That seems pretty steep.
Yes.
In terms of the slope.
Yeah, but I looked it up and it said 3.8. So I was like, that's really, but no one else is doing that.
No.
All right, we have a new, and I have a,
nice.
Oh, I forgot to grab my rack. I have it right here.
Yes.
These are these microfiber ones. They just erase very much.
I love those things. They're so good for all kinds of deals, and they get rid of dust also really well.
Yes, but they clean faster.
Well, and they clean well. Oh yeah, I'm sure. All right, so here is the next problem. Yes. A drill digs at 3 feet per hour and starts 2 feet in the ground.
So what's happening in this scenario?
Oh, it digs at 3 feet per hour.
So is it going up or down if it's digging at 3 feet per hour?
It's going down.
Exactly. So our rate, I'm going to do one of these thicker, darker ones. We'll just do, I'll just do the same one. That blue probably shows it really nicely.
Okay.
All right, so my rate or my M or my slope, which I say rise over run, all these things are the same thing. I also, for what I've been doing today all day, is change in y over change in x because that means delta, which is change. But instead of writing literal words change in y coordinates, you just kind of get stumped and it's a lot to write. So that's how
that's very good.
I change in y over change in x. So what's happening in this scenario? You said we're changing at
3 feet per hour.
So we're going down 3 feet per 1 hour. So that's our rate or our m. So now for our equation, y equals mx plus b, our rate is y equals negative 3x. But where did we start?
We started at 2 feet in the ground.
And now is that positive 2 or negative 2 if we're in the ground?
2.
Yes. So our initial value, our b, is negative 2 feet because it's 2 feet in the ground. And that's also called our b, which is our y-intercept, which I showed you why, because our 0 we're at 0 time, and we start at that. So it's any 0 value in y because our x is 0, but we also call it our initial value in real life because it's where we're starting at 0 time.
Okay.
So to graph this one, we will, now we're going down. So instead of being in quadrant where we were in quadrant 1 because everything was positive, what quadrant are we going to be in?
We're going to be in this quadrant lower right.
Yeah, so quadrant 4.
Quadrant 4.
So we're starting at
1, 2, 3, 4. 1.
Yeah, so it starts here in positive land and then goes counterclockwise.
Oh, thank you. Good.
1,
didn't
2,
know.
3, 4.
Got it.
I think it's because you usually are here, then you're next usually here. And
Okay.
then
That sounds good.
What I
Sounds
feel
good to me. Okay.
So that's our y-intercept, which is -2. And now since it's down here, we're going to label up here. So this is now time, and then what's my units?
Your units for time are feet per hour.
So
hours, sorry.
Yeah, hours.
Hours.
And then my
feet.
Yeah, my distance here is feet.
Yes.
Yeah. And then we're just going to go, and if you want to do that, if you want to go down
Sure, I'd
3
love to.
over 1, yeah, any colors, fine.
Sure, I'll take this one. Okay, so I'm going to go down 1, 2, 3,
And you can actually draw an arrow down and arrow right so people see.
Oh, good.
that.
Okay. So
Down
I'm going
3.
1, 2, 3,
Yep.
and then I'm going over
To the right one, yep, because 3 feet down, 3 feet every 1 hour, and
Okay,
then do
so
it again.
1, 2, 3, over. This looks like it reminds me of Steph Curry's thing.
It is. Except it's 3 instead of
Now
4.
we're- yes,
So go ahead and make
that's
those
right,
points so that you see where you're supposed to connect. Yep.
Okay.
And we don't know how far it's going down, but that's where we
This
start.
again.
Yep. And then you have the
My
ruler.
ruler. Love the ruler.
And it is,
Wait, I have to do this
I
as
did
well.
a tree thing where you just basically do straight lines to make curves, but it was just so students could hold a ruler down. You don't realize, especially when you've been in remote, that people don't know how to like push down without it like swirling around.
Oh, yeah, that's true.
And then go ahead and put an
yeah, an
arrow
arrow.
just because it's going
Okay.
down because we don't know.
Sweet.
But what would be nice for someone to find out if they needed to go a certain distance? Why would this be helpful?
Then they would know how far down they were going. I mean, if you want to know how far
If you
you're gonna-
picked how far down, but then it would tell you maybe
how long it would take you.
Yeah, like how many hours someone might have to be there to watch it or things like that.
Right.
So they're like real life. And
Yes.
I'm going to put this equation. So this equation was y equals -3x minus 2.
And there's so many things you can use a drill for to do that. I mean, you could use you could do that to make a fence, although that's
Or a well.
pretty darn deep, or dig it for a well for sure.
Yeah.
Yeah, or find minerals or whatever.
Yeah, so this one, if you notice the difference, this is going downhill, decreasing, because we're going down, which we have a negative slope. But the other one points were going up, so we had a positive slope,
Yes.
which was 4.
Nice.
All right, I have one where we're going to do a positive and negative mix.
Okay. Nice.
Okay.
Okay, here we go. So the first one, and this is very appropriate because the Midwest right now is freezing. They're in what's called the Polar Vortex, which means is the jet stream goes way, way down, and it's just so cold for them.
So cold.
Relatives, my brother lives in right near Philadelphia, and it's
Cold.
chilly. The snow level starts at 3 inches and is falling at a rate of about ½ an inch per hour. Okay.
And then we're also going to do?
The snow level starts at 7 inches and melts at a rate, this is good, of 1/3 of an inch per hour.
So we basically have a...
build up and
yeah, so we can kind of
getting
see
rid
the difference.
Yes.
So
Okay, that's good.
what is my rate here, my slope or my rate?
Your rate is ½ an inch per hour.
½ an inch
0.5.
per 1 hour, but when
Yes.
we divide by 1, that's just going to be,
½ inch.
my slope is 1 over,
1/2.
Yep.
Okay, sweet.
and then what's my B or my initial value?
3 inches.
3 inches, yep. And then so if I have y equals mx plus b, what is going to be my equation for my first snowing increasing?
So for first snowing increasing, you're going to take
Equation.
1/2
Yep.
times, or plus, wait, x
Yep.
plus b, which is 3.
Yep.
'Kay.
Perfect. So we're going to do the other one also. I could grab like a different
All right.
color.
Yes.
Just so we can see the difference.
Good.
So what's happening? What's the rate or slope in my melting scenario?
This is 1/3 of an inch per hour instead of half.
Yes, 1/3 of an inch per hour. But when we divide 1/3 by 1, it's just the slope of 1 over 3. And this
Yes.
is my change in y over change in x. I want to make sure I
Yes.
write that because people forget. They need to step up a stair, but not just kick forward. Because we alphabetically graph X, Y. But for rate and slope, which are the same things, it's rise over run, which is different.
Yes.
All right, and then my initial value for my melting snow?
7 inches.
Initial value, 7 inches. All right, and what's my equation then for my second one?
It is y equals 1/3 x plus 7. No, minus. Oh my.
No, it's 7. It's starting at 7 and melting.
7.
Yes, yes.
Okay.
Because it's starting
That's right.
up and
plus
then coming
7
down.
and coming
yes.
down. Okay, thank you.
All right, let's do
That's
two
good.
different colors. So do you want? You can start it.
Sure, I'd love to.
We because we're going both ways, we probably will label it. It'll be an interesting label. We can just
So I
graph it
start.
without labeling.
So
start at 3.
Start at 3. So 1, 2, 3 right here. Okay.
And then go up 1 to the right 2.
Up 1 to the right 1, 2. Like this. Okay, sweet. Up 1, 1, 2. Up 1, 1, 2. Okay. Is that good?
Yes, and then we could put a line through it.
All right. We'll do.
We'll do a different color. Here you go. And we'll put a
thank
line
you.
through it.
Line through
And
it.
this is the one that's going
This
up.
is accumulation of snow.
Yeah, so it's building up higher, higher, higher.
Okay.
Which is probably happening.
good to take
I don't
the
know,
top
some of
off
these
before you
weather
do
have
this.
been shifting. You know, where it's like hot, cold, hot, cold. So
I
it
know.
might be melting in the same week that
That's true. That's true. And we had so much snow. Oh my gosh, did you see when you were driving like Neeland how the snow was up there and then it's melted off at this point.
All right, so now that's it's going up. So now we're going to graph. We'll do a different color.
Okay.
And we're going to graph the snow melting.
So we're starting at 7.
7
3,
inches
4,
of snow.
5, 6, 7. Okay, here we are.
And now we're going, oops, we did last 1/3, but actually we're going, this is good, this happens.
Okay, good.
We're
yes.
melting, so what do we need to put in front of our 1/3? Because we're
Negative.
melting. Negative 1/3
Yes.
inch per hour,
Yes.
which means negative 1/3 and negative 1/3.
Okay.
So it's going down.
I'm going
1/3.
down.
Yes.
And do I stay over here? And
Yes,
I can
so-
cross through this? and
Yes,
it's
you can
fine?
cross through it. Yeah.
Okay,
I mean, these aren't happening. Well, it could be happening simultaneously, but it was more just to show you some go up and some go down.
So I'm going per hour 1, and
down
then I'm
1
going
to the right 3. Down 1 to the right 3.
down 1 to the 1, 2, 3.
Right
Did I
here.
mess up? Oh yeah, wait.
No, here.
What,
3.
What am I doing? Not what?
Down 1 to the right 3. There we go.
Down 1. Yes, right. Okay, for some reason I was like, what? I have to be over here. Okay.
Down 1 to the right
Good.
3. Yep.
So same here. Down 1.
Yep.
1, 2, 3. Oh, Down 1, 1, 2, 3. Okay.
All right. Now we're going to connect it.
Connect
We have
with a
our
different color. I'll do the red. Okay. All right. Yeah.
Pretty cool.
Very cool.
So we're still in quadrant 1 for both of these, so we can label it.
Yes. Okay.
And put an arrow.
All right.
Now, obviously, this one will run out eventually because it will get down to 0. But this
Yes.
one, it will go. At some point, it will stop and melt, but it could go up higher.
Okay.
So this one is y equals 1/2 x plus 3.
Yes.
So we're starting lower at 3 on the y-axis, but then we're going up because it is snowing
Yes.
more.
Yes.
But on this one, we're going negative 1/3, so we're going down. And I sometimes, I'll write instead of like rise over run, I say fall over run. Because I'm like, you're not really rising.
That's good.
You're falling.
Yes. That's good. Fall over.
You're going down 1 to the right
Yes.
3, versus
Yes.
here we were going up 1 to the right 2.
Yes.
So it's very different, and that's what we want to see from left to right. We have melting going down, and we have
So
snow going
at
up.
1, 2, 3, 4, like, well, a little between 4 and 5, hours 4 and 5, they do cross paths.
Oh yeah, so if this was happening at the same time, they would both, we could figure that out. Well, I mean, we don't have to figure that out because that's a
No.
whole different
We're
lesson.
good. Let's not do
But
that
let's actually write, we can, so it's time is in what? Hours, it
Times
looks
in
like?
hours, yeah.
Hours. Oh, and I haven't been doing this. I always write arrow right X and arrow up Y to show our
Okay, that's good.
directional.
That's very good.
And then, I forgot this does not
This
have
was
it on there. which
amount of
makes
snow
sense.
or something, or
Yeah,
snow level,
so
snow level.
Yeah, so snow,
So it's a
snow level.
distance,
Yeah,
yeah.
height. Snow level in what, inches?
Yes.
Inches. Yeah, so we could just kind of figure it out the look. So if we, not exact, but estimate. So this is 3, and we're going to go to 7, and then that's what, 4, 5, maybe 5.5 hours. Not exactly, but approximately 5.5 hours. Or sorry, at approximately 5.5 inches.
Inches.
And like you said, at about 4.5 hours, almost 5 hours,
Yes.
they'll both be at about 5.5 inches. But yeah, that's just estimating. That's a whole nother lesson when you find where two things intersect. It's a whole algebra thing, and another time.
Sounds
All
good
right. Still have time. We do another one.
We do.
Okay.
Nice.
What's the next
Rain.
one?
Rain is good.
Yes.
We don't have any right now, but that's okay. We have a little break. It rains 2 inches every 3 weeks, and the rain starts at 4 inches.
All right. So what happens in this one?
This one, the rate is 2 inches every 3 weeks.
The rate or slope.
Slope is
M. I just keep writing it all every time. I just write
good.
all the change in Y over
It
change
helps
in X.
to know where you are.
Is 2 inches every 3 weeks. So that's a slope of 2 over 3.
2 over 3.
Yep. And what's my rate? I mean my Y-intercept.
Your
my
Y-intercept
initial
is
value,
4 inches.
which is my B, which is also my initial value, is 4 inches. So at 0 time that they started tracking it in this situation, it would start at 4 inches. So you can go ahead. Oh, what's the equation? Because then we write the equation.
Yes, the equation. The equation is Y equals 2/3 plus 4.
Y equals 2/3 X. Oh yeah, plus
X.
4. Yeah,
Sorry, yes.
I'll write Y equals MX plus
Yes,
B because then it
forgot
helps our brain see
Yes,
both.
I like that.
All right. So we're going to go ahead and start at 4
Okay,
inches.
4 inches. We're going up 1, 2, 3, 4. There's 4 inches.
And then my
We're
slope is
Over 2, down 3.
up to
up
the right,
to.
rise over
One,
run.
wait,
Yep.
wait, 1, 2, and then 1, 2, 3.
Yep.
Got it. Oh,
2
cool.
inches every 3
1, 2,
weeks.
1, 2, 3.
Yep, stepping up a stair.
1, 2, 1, 2, 3. That's great. That's a
Yep.
really good analogy.
Yeah, I was saying like it would only be a malfunctioning robot that would kick a stair. You would kick it once and then lift your foot. Like,
That's
it's not like
right.
that would keep happening.
That's true. You hope, anyway.
But yeah, but I was like, you're
If
going to
you're
stub
really
your toe
tired,
if
you
you
might
do not lift your foot.
do
You'll
it.
stub your toe.
Unless
so
you have
lift your
something
foot.
wrong with your
Yes.
nerves or blood or
Yes.
something. Okay.
So I just wanted to mention one other thing. So sometimes you'll see in books, it'll call this a slope triangle. See how it makes a triangle? But I don't want people to get confused. What is a slope triangle? It's just saying we're showing the rise, we're showing the
Yes.
run, we're showing how it's related to the line, and you will hear that as a slope triangle. So I
Okay.
just wanted to bring up that
That's good.
vocabulary
That's
that comes
nice.
up sometimes.
Okay.
So we're starting at 4, and
Yes.
we can label, oh yeah, arrow
let's
right
label.
X, arrow up Y.
Cool.
And then what's my
Weeks.
Weeks. So it's
Weeks.
time in weeks. All right. And then what about this?
This is inches and inches of rain.
Yeah, so I think like rain amount maybe?
Rain amount? Yes, rain amount. That sounds good.
Rain amount. And that's in inches.
Yes.
I mean, a lot of it when I say we're labeling graphs is like someone looks at this, they need to know like, oh, it's weeks, it's rain, okay. And then we would make a title or something like
This
that.
is so important. This is a math class, but in science, this is used all the time in all sorts of different ways in many different science classes. In chemistry and biology, when you're looking at predator-prey, in biology, when you're looking at moles, the changes of reactants and products in chemistry. I mean, we do this all the time.
Graphing, and I spent 3 days with my 8th graders, full periods doing 7 graphs because I wanted to make sure they could hold the ruler down, X,
Yes.
Y, label,
Yes.
you know, because there's just so much you have to be able to do, and then it's going to help you. I said in high school and college for math and science, it's going to be
huge.
helpful in statistics. And all kinds of
Statistics, oh
things.
my gosh. You
Like
and
that.
me, we're both thinking the same thing, yeah.
All right, the last one.
Okay.
Oh no, I have 2 more, but
Okay.
we don't have to get through all of them.
All right, sounds good. Now we got a rain bucket. This is good because weather-related stuff.
Yes.
Nice. An 8-gallon rain bucket decreases by about 1 gallon per day. I'm assuming that's evaporation.
Or I was thinking they're water. Sometimes they hook it up and like water a plant or something like that and utilize the rain. I mean, I don't know why you would. But
Oh,
maybe
sure.
like through your wind. I don't know if you had a plant in your house. I was just thinking sometimes
No,
people
you'd use
rain
it to
buckets.
water your plants. That's
Yeah.
great. Of course, because that's way too much evaporation. I don't know where you
I was
live,
just
but
thinking
it's
they were using
certainly
it
not
for
happening.
different things and then they'd have to fill it again and start over. I don't
That's
know.
great. Makes more sense than evaporation. Sorry.
Equals
Especially that amount.
rate equals M equals slope equals change in Y over change in X, rise over run. And this is decreasing, so we're going what?
It's 1 gallon per day, or
Negative one
negative 1
gallon per
per
day.
day.
Yeah, per 1 day. So actually, we just write, the slope is actually just -1.
Negative
And this is a
1.
little trickier, that's why I did this one also.
Okay, good.
And then what is my Y-intercept or my initial
Here
value?
it's 8 gallons.
equals B equals initial value.
Yes.
Is 8 gallons.
Yes.
So what is the equation here? This one's a little trickier.
Okay, so it's y equals -1x plus 8.
And then we can simplify that, and it actually looks like what?
Y equals -x plus 8.
So people see this equation and they don't realize it's really down one to the right one. So sometimes you have to go, okay, one is the identity. If it's missing anything, we need to make sure where are we missing a multiplier or dividing, same thing, 1 over 1. So that's just gets kind of tricky. So we're going to start at 8. So go ahead and introduce.
Okay, yes,
I'll start at 8 and then you do the slope.
Okay. Okay.
1, 2, 3, 4, 5, 6, 7, 8, and I'll put my arrow up Y and my arrow right X, and then you're going to go down 1 to the right 1.
I'm going down and then to the right.
Yep, down 1 to the right
down
1.
to the right. Oh, this is a nice little thing here. This is
yep, and then eventually this one will stop because we can fit it. It will run out, and then you'll have to fill it again.
Cool.
So when we connect it, we'll just connect it to the bottom.
Okay.
Here we go.
Okay. Connect it to the bottom.
You don't have to like put an arrow is what I'm saying, because this has
Okay,
a finite amount.
Sure, that
and
makes sense.
For sure has a finite. Others you'd need more information.
Okay.
Yep, and then we'll go ahead and label. So this is, what's the X independently?
This is time, and it's in
days.
Days, yeah.
Independently, time and days are always passing. And dependently
is amount of rain.
Rain bucket
rain
level.
Bucket level. Oh yeah, right. Yes.
Level, and I think we're doing gallons. Or I guess it's not level. I don't know.
It's not level.
Volume? Maybe?
Yes, volume. Volume. Good job.
We'll do volume.
Absolutely.
I mean, they might have lines on it, like gallon, 2 gallon. So it might be level, but it's really volume.
Yes.
And notice it's going down. It's going down 1 over 1 because and then it's going to run out. What day is it run out? 3, 4, 5, 6, 7, 8 days, right? At day 8. Because you're going 1 gallon per day, and then you have to start over and wait for the next rain to come and fill it up again.
Yes. I know, it's pretty exciting. I have a rain gauge. Do you have a rain gauge at home? Because I did, and it kept falling off because the wind blew it off. And it broke,
the wind.
And it hit 3 inches, and I'm like, why isn't it getting any higher? And then I felt it, and it went kirk, so I had to buy a new one. They're not expensive. Like, they're $5 for a really nice Taylor rain gauge.
And you get it then you check per day?
Yes. Yeah, I do. I love that when it's raining, of course.
Well, this, just looking over, we don't need to finish the last one, but, just looking at even these two, like, you're starting at 8 and you're going down 1 over 1, or you're starting at 4 and you're going up 2 to the right 3, and just knowing that if you think more about the rate, if you label it, if you do more real life ones, then your brain can go, okay, I start at 4, I go up 2 to the right 3, but you've practiced it in real life context, so then your brain can go, oh, that's my starting, that's my slope. Oh, that's going up, that's going down.
Yes.
And then it just helps it make more sense than if you just graph this equation. You just forget and you don't know why.
Y and M and X and B, right, exactly. Variables that make no sense unless you apply them to something.
Yes.
Yes.
Well, that's exciting.
Yeah,
I really love graphing. I do. I was so excited students were in class getting to graph. So enjoy graphing at home.
So good. Yay. So
Thank
glad
you so
that you
much
guys
for
have joined
tuning
us.
in.
Yay. Thank you. Bye-bye.